All right, folks. I don't know what happened. I thought we were live, but I guess maybe my network connection dropped or something. We're gonna try this again. Probably a little quicker this time because some things don't have to build. But basically, what I wanted to do was walk through the process of using Spinnaker to build an application and leverage a registry for resources. So all of this is a UI. It's not currently attached to anything. So we're going to use this application, Ruby Hello World, this little application on GitHub. Just a real simple Ruby app. It has a route map, a route route, and a route with a parameter that can get passed in. Actually, I keep meaning to fix this. I believe this is supposed to have an at in front of it. Application parameter. Well, hopefully it doesn't break the app. Well, I guess we'll find out. Hey, that's part of this whole process. So in addition to this, we have an example that the application when it runs, this is the kind of output that we get. So it looks pretty. We also have the application pushing the data into our container registry. In this case, we're using Docker Hub. You can see that there currently are 4 releases that we've pushed into the environment. We'll push another couple into the environment here in just a second. So first thing we want to do is make sure we have Spinnaker running, and first thing we want to do is make sure that we have Spinnaker running. We can do that here. I'm in the Spinnaker class, Spinnaker Helm directory, and that's my Helm chart directory. So there's a Git repo for this as well in the Cumulus Tech repository. There's an RBAC manifest. I found that basically you had to go create a service account and a cluster role binding against the default namespace for a cluster admin so that the Spinnaker charts would actually work properly. So kube control create -f RBAC. This is going to complain because it already exists, but that's okay. The point is that it needs to be there. And the next thing that we had done is we actually launched Helm. This is actually pretty easy. Helm install, name, Spinnaker, and then the repository. I've already done this. It takes about 10 or 15 minutes usually to boot. If you haven't already downloaded the images and you're doing this on a laptop, first off, in the previous sections in the class that we've done, we talk about Minikube and setting it up to have at least 8 gigabytes of memory. Spinnaker needs a lot of memory. So if your laptop doesn't have at least 16 gig locally, don't even try to do this on a local laptop. Spin up an instance in DigitalOcean or Amazon or Google or Packet or Azure or Alibaba or pick your cloud provider. There are lots of providers. Most of them will even give you some free credit if you haven't used them before to play around with this. But you do need a machine with some memory to actually do this properly. Anyway, so we launched that Helm chart and kube control get pods. We have the service running. The important resources are the fact that Jenkins is running. We're not actually using Jenkins for this particular run through, but there's a Jenkins instance. There's an S3 backend. In this case, we're using Minio for that. Redis database for some state, and then the actual Spinnaker application component itself. And the one that we really want to play with is the deck because that's the UI, and we want to expose that. So we're going to use the cheat way of doing it, which is a port forward. Kube control, port forward, pod name, and we need port 9000. That's the port that Spinnaker actually uses to provide its UI on. Now there's no control on this UI, so here if we pop into our web browser and we refresh this, since this was the old version, we see that there's nothing here, but we are actually live. And now we can actually start manipulating the environment. So there's 2 things that we need to do. So Spinnaker itself is running, that's great, but we also need to make sure that we have a way of creating and deploying our container images. Now, there's a couple of different pathways. Other tutorials actually use the Docker Hub auto build from GitHub push model. that's an appropriate model. I happen to really like this tool called Draft, and so that's what I've been using. Now here I'm still in the directory, but I'm going to get my application, and then we're going to use Draft to actually push a version of the code. So git clone. Actually, clear this. Okay, git clone HTTPS GitHub. rstarmer ruby underscore HW, and I'm going to put it into Ruby hyphen HW, just because names are important, and names in Kubernetes are often DNS names, and DNS names cannot have underscores in them. So even though my repository, which is now multiple years old, has an underscore in it, I'm going to use the hyphen for all the code that I do. If we go look in here, and now we have our little app, and actually I'm going to do one more change. I'm going to move this to app.rb. And I'm going to do that because Draft actually has some defaults. And so we can do Draft create pack equals Ruby. Basically, we're saying, hey, create a Draft environment, which is a Docker file and a Helm chart that map to a Ruby application. And the way that Draft thinks about things, if we look at the Docker file real quick, we see that Draft is expecting here at the very bottom app.rb to become the name for this particular application. So let's follow along with that. The other thing that the system needs, Draft wants to know what registry to talk to, and you can configure that through the draft config command to point it at the registry, and we've already done that. So we're pointing at our Docker Hub registry. And we can see all these pieces come together by doing draft up. And this to me is sort of part of the coolest part of all of this. The image build, now this is pretty quick because I have built this image before on this machine, and so I didn't have to download like the default Ruby image or any of that sort of stuff for this particular environment. It is pushing an image up to Docker Hub, and so we had 4 here in the hub, and we can just make sure that when the push finishes, which takes I think like about 15-20 seconds, okay, it's pushed and our application is released. We'll look at that in a second as well. If we refresh this, we'll see we have a new image here. Great. So we're creating new tags, and that's important because it's the new tag in the repository that's actually going to trigger our pipelines in Spinnaker, which is why I wanted to get a path to do this. Like I said, another path is to push an update into a Git repository and link the Git repository with Docker Hub is another approach, and actually Docker Hub has a build process, so it'll do that. This is the tool I like, Draft.sh. Simple to install. Basically, it's download an application and then run an init script, and boom, you have a nice environment to sort of automate this process. I like this from the developer use case perspective. Hey, you want to test something out? Use Draft, then commit your code and push it into GitHub, and then let Git CI do the rest of it and potentially trigger this pipeline. You'd normally trigger this pipeline through Git, but the point is that the pieces all come together. Now, one of the things that Draft does is that Draft does use Helm to install an app. So we can have a look at that. Kubectl get SVC, for example. And we see beyond all the Spinnaker stuff, there's this Ruby hardware Ruby service. That's great, but we're going to want to clean all that up. The same thing is true for our pods. We have a Ruby pod, and we want to clean that up because we're going to use Ruby HW as our namespace for the Spinnaker process. And the way you do that is actually using the Helm tool. So Helm is installed, that's how we installed Spinnaker, and it also installed this Ruby HW app. So we're going to do Helm, delete, purge the system of anything that is Ruby HW related. And so that'll clean that up. Now, so Draft doesn't actually have a draft cleanup, which is, I think, kind of interesting. You have to use Helm for that, but that's okay. In general, the idea with Draft is that you just keep building new versions of your environment. And we're actually going to do that. That's how we're going to trigger the system. All right, so the rest of this we're actually going to do mostly in the UI. So we're going to pop over to our UI page here. So here we are in the Spinnaker environment. And what we're going to do now is, first thing we're going to do is we're going to create an application. Yeah, I see it actually shows up here that this was just created, and we're going to get rid of that one. Actually, no, we're not either. We're going to use that one. Why not? Yeah, so we'll just go ahead and reuse this one. I mean, creating an application basically is giving it a name. Or we can go back here and we can create an app. And description, Ruby. We don't actually have to provide any of the rest of this information. So we're just going to use the RUHW app. So we're in this application, and now server groups basically map to replica sets, although you can now enable a deployment as well through Spinnaker, and that's how it maps to Kubernetes. The other thing is load balancers, and we're going to create a load balancer first, because that way our server group just gets associated with it. We're going to call our stack, let's just call it dev. That's basically what we always call it. Our input port is going to be port 80. Our target is actually 3000 because it's a Ruby app, and that's the default rack port for that. And we're going to expose via node port rather than cluster IP. We don't have a load balancer here, and I haven't turned ingress on, so that's the simplest way to do this. This should go pretty quick. All right, so now we have a load balancer, and if we refresh this, I think we'll probably even see that it exists. It will show up. There it is. There's our load balancer. Great. So now we go back to our clusters page. Now clusters are server groups, like I said, replica sets of a pod or set of pods and or set of containers in a pod. So we can create a server group. We're just going to do this because we're going to use this as a template for our environment. Stack, we're going to stick with dev. We don't have to really give it any details. Container, we want to select Ruby HW, and we can select any container or any tagged container in here. And since we have a couple of them, if we wanted to, we could check. Oops, hello. We could just check here and see. Yeah, 4A2E is the latest. So 4A2E. Okay, so we're using the latest. So we're gonna build with that. We're gonna tell it what load balancer to connect to, and that's the RUHW dev. It's the one that we just created here a minute ago. Let's make sure that we have a couple of these guys running. No, we don't need 12. How about we just do 2? We could turn on auto scaling, but there's really no point in this particular test. And that's really all that we need to do here. I always like always as my setting here. We could add some readiness and liveness probes, but again, we don't need to do that. This application, this container doesn't actually give us any kind of a liveness response. We'd have to add a specific route for asking for that into the app, and we don't have it right now, so that really wouldn't help us. But if your app can support those, which really I think, especially for microservices world, it really needs to be able to do, that's where you could actually configure that. And again, this template is going to then be used when we create the pipelines here in just a minute, because we're going to pull from this template and then just modify it slightly to say, hey, use the latest tag instead of the tag that we had started out with for that particular environment. All right. So our environment's up, our machines are running, the system is happy with that. So now we have created a server group. Now we get into the real functionality. So this was all manual. I could have done this a number of different ways. In fact, the draft up created exactly this same environment, a service with just load balancing to a couple of back-end resources. So perfect. We can prove this same functionality here through Spinnaker. But what we really want to do is we want to create a pipeline, give it any kind of a name, but let's define, how about registry to dev, because that's kind of what we're doing. Again, any name that we want, but we can call it what we want. And what we want to do here is we want to actually look for a Docker registry input. Our registry is from Docker Hub. Our organization is our rstormer organization. Image is the Ruby HW image. And we don't have to define a tag. It'll just use the latest at the moment for this. And that's just the fact that something is happening. Anything is happening against this image is really what we're looking for. Okay, so what we've now created is the input. This is the thing that triggers our pipeline. Now we can add some stages, because as soon as we get that, the first thing we want to do is, let's go ahead and deploy against that stage. It doesn't depend on anything because it's basically coming from configuration, so this mapping already exists. What we're going to do is we're going to add a server group, and we're going to do it from a template. And we already have our template here, right? So that's the one that we built. We're going to use that as a template. Now you'll see that the template includes the container name. We want to actually get rid of this one and grab tag resolved at runtime. So it's the same container, but in this case, rather than the tag being included in the container list, we're going to get it only at runtime, which is really the key. The rest of this should all be the same because this is just pulling from the example that we had. Again, I like always. I thought it was always. Maybe I forgot to change that. We can say add. So real straightforward. If we see a new tag or some change happen to the tags within the registry, then we go and deploy it. That's great. But now we have two systems. So we're going to be smart, and we're going to create another one. And we're going to say, rather than deploy, we're going to say destroy. All right, so I don't know what happened there. Depends on deployment being completed. So we're going to destroy our servers, and we're going to say that we're going to do this out of default namespace, and we're going to see what clusters exist. Cluster is basically mapped at the load balancer level. And our target is not the newest server group, but the previous server group. So whatever was there before, we want to get rid of that one after our deployment is completed. Perfect. And that's really all that we have to do. We could send notifications. That's sending mail, but we didn't configure mail in our environment, or Slack or HipChat or any others, so we don't have any of that. So this is our first pipeline. If we see a tag show up, or a change in the tag within the registry show up, deploy a new server group, just like our old server group, and then get rid of the old server group. There, perfect pipeline. Now, one of the cool things we can do is we can actually start staging, connecting pipelines together so they become stages. And so the next stage we're going to do is we're going to say, let's add one here. Create another pipeline, and we're going to call this one manual approval. Okay. Now, what we want to do here is we want to add a trigger, and in this case, instead of coming from a registry, we want to come from a pipeline. Well, there's really only one pipeline available, which is our registry to dev deployment. If that was successful, then we want to grab this. And what we actually want to do with it is the next step. And we're going to say here, manual judgment is our step. Verify that application deployed and is running. And really, it's basically that easy. All right, and that's the end of it, end of this pipeline at least. So great. If we go back to our pipelines, we see we have the two pipelines. They should be connected together, and we see that we still have a cluster running, and that's fine because that'll get cleaned up if everything works. So now we go back to our application. And so here we're back in our application environment. We can do draft up again, and that's going to do the same thing it did before. It's going to build an image, and it's going to push that image to Docker, and even though it's no different, we're still going to get a new image ID, and so we can actually go and check in our Docker Hub. So 4A2E was the last one. Once this is done pushing, we'll hopefully have a new one. refresh this here. Maybe. Oh no, I guess it said no. It's really no different. So nothing new has happened. So let's go and make sure that we have a new one. By changing something here, what we can do is we can just move this here. Try this again. Draft up. Really didn't like that. Yeah. Okay. That should not have triggered anything, so we can go check, make sure that our pipelines are still just sitting there doing nothing. Okay, that's a good sign. So now we are building a different image. And okay, so oops, go too far. So now hopefully we get a new version. There we go, 4320. And if we look, we still have just our version 0 running. Actually, we can cube control get pods grep image. Oh. But here now we see we have a new version running, v1 instead of v0. So if we pop into our environment, we see that our pipeline is running. That's great. That means that we're building our environment. It found a new image detail and is now running. And so it's doing the deployment stage. Once the deploy is up, what we should actually see is that the destroy process will start. And right now, oh, I know why it's not giving me any output. If we ask this guy, and we ask for some data, minus output YAML, and then we can grep for the image. Oh, except that's not been cleaned up. Okay, so if we look for our pods again, clear this up just so it's easier to see. Okay, we're going to look for our pods. Going to look for our new version. Cube control get pods name -o YAML pipe grep for image. So here we see our image is 4320, and if we go back to the hub real quick, we see that the latest image was 4320. So that actually maps the way we would hoped it would. In our pipeline, so the destroy, okay, so the deploy completed successfully, the destroy completed successfully. Manual approval will show up here next because that will have been triggered. And if we look at our pods, we see that we only have version 1. We don't have version 0 anymore. I'm actually going to clean this guy up to helm ls, helm delete, purge, just like what we did before, ruby-hw. Get our pods. We see that it's cleaning that one up. We have our version 1 running. And now we also see that we have a manual approval. Hey, did our previous build actually work? And I'm going to say yes. Great. Happy about that one. And, just to really prove that this really does work, cube control get pods. We can just do this back and forth as many times as we'd like. We'll go ahead and modify our app again. And let's fix that change that I did before. All right. And we can do draft up again. Build an image, push it. Really, that's all we want, is we just want this thing to push this image to draft, right? I have no clue why my stream keeps dying. But anyway, so we did another push to draft. And what this will eventually do, because we pushed another image, if we go and look at our hub, refresh this guy here. All right, we have a new image to AAD. Come back to pipeline, and we can just sit here and watch for a minute. Refresh, and sure enough, we have a new one running, and you can see that it's running, and it's using the 2AAD image versus the 4320 image. And what we'll end up with is we'll end up with a V02 or 002 set of pods. Actually, we'll probably see those already. And there's V002, and it'll go through, and once it's happy that they're running, it'll delete the V001 pods. And obviously you can do a heck of a lot more with this, but that really shows the function of the Spinnaker environment. And so for those of you that were on the stream, thanks so much for joining.